So say I ask you to graph, oh Jeff, let's see. Yeah. Say I ask you to graph this, right? And you can look at your test. What's the very first thing I asked you on number 2? And very first 2 things. End behavior. So this one's end behavior is easy to see, right? What's this guy's end behavior? What's the highest degree? 3rd. So what's it going to look like? Can anybody do it with your hands? I like it. Yeah. Okay, I love it. So the end behavior here is not negative, so it's going to be like this. Okay. Then I'm going to ask you find all the intercepts. Why is the y-intercept crazy easy? Second, make x 0. And what's the only thing left if I make all the x's 0? Make all the x's 0, what's the only thing left? Negative 20. That's easy. What's not so easy? How do I find the x-intercepts? Factor. I love it. So one of the first things you're going to have to do is to factor what I give you. This one is easy. Let's see if you agree. Go ahead and take a minute and factor that. I should have done this. Let's do one thing for me. I'm going to change one thing. Watch this. I'm going to make this, I wanted to go a little further. Make this a minus and this a plus. See that? Make that a minus and that a plus. Okay, that'll make it a little bit better. So make this a minus 4x and make this a plus 1. Bless you. What was that? So what method are you guys using to factor this? Grouping, because there's 4 terms, right? If there's 4 more terms, you try some kind of grouping, right? Yes.
To determine the degree,
Yeah.
do you add all of them?
No, definitely not. Because the degree of a polynomial is the degree of the highest term. What you're thinking of is if I gave it to you already factored, you have to kind of undo that factoring and think, if you did multiply this out, don't. If you did multiply this out, don't. If you did, the highest degree would be 5th. Right, because this would multiply and you get x cubed plus shit, and this would multiply and you get x squared plus shit, and then this would multiply and you get x to the 5th plus shit.
Okay. So the 4x doesn't count?
Say again?
The 4x doesn't count when it comes to
This?
the degree? Yeah.
Well, no, not really. What's the degree of 4x? That's that term. What's the degree of this term? 1. What's the degree of this term? 2. This one. This one. Beautiful. The degree is how many variables you see. I don't see any, so that's a 0th degree. What's the highest degree? 3rd degree. So the whole polynomial is 3rd degree. Here, I can't see what the highest degree is because it's freaking factored. If I did multiply it out, I would get x to the 5th plus lower terms, so it must be 5th. Okay, I like it. So how do you factor this? What comes out of these two? X squared. And what's left? And what comes out of these two? Negative 4, good. What do you get? X minus 5. And what tells you you're on the right track? what tells you you're on the right track? These are the same. If these weren't the same, what would you do? Erase that shit. You made a mistake. Or it's not factorable. That could be true. That would suck, but it could be not factorable. Right? So what's the next step? Yeah, what can I take out? Take an x minus 5 out, right? And what's left? X squared minus 4. It doesn't really matter which one of these you put first because it's multiplication. 7 times 8 is the same as 8 times 7, right? Everything I'm doing right now needs to be easy. This is easy. Grouping is fantastic. Right? And what's the last, am I done factoring? Nope, shit. This comes from the right, and what's this? X minus 2x plus 2. Okay. And then you can find your x-intercepts. They each have multiplicity 1, which means what are they going to do at each of them? Are they going to turn or go through?
True.
By the way, real quick, watch this. Let me see if I can make this. You could argue that that's turn. You could argue that that's through. I love it. I don't know. Some of you guys, maybe that's why some of my colleagues use the word bounce instead of turn, because some of you guys write in a way that turn looks like through, which is exciting for me. Trying to grade. Are you guys? It's sort of like true false, and you put this. What the shit is that? I've actually asked somebody. It was a true false question. They put this, and I'm like, which letter is this? And they said, well, what's the answer? What? How dumb do you think I am? So yeah, okay. I don't think it was on purpose. I don't know, but make it really clear. Okay. Oh, okay. Sorry, just thought I found that funny. I was like, what is that word? Okay. Is it pretty cool? That I mean, and then you do all the normal stuff for this. So the reason I wanted to do this real quick was I wanted to point out how important factoring stuff is, right? Because what are the x-intercepts now? 5, 0, 2, 0, negative 2, 0. Now let me make a connection. Let me see if you guys can help me make a connection. If I synthetically divide this by 5, what should my remainder be? Does x minus 5 go into this evenly? Yes, right? Right? Doesn't x minus 5 go into it evenly? So the remainder should be 0, right? So let's see. If I synthetically divide by 5, what would I put here? Do this in a different color. So right now I'm doing something that's not necessary. I already know that that's an answer. I already know that x minus 5 is the root. But I want to verify. If I synthetically divide by 5, the remainder has to be 0 because x minus 5 goes in evenly, yes?
But don't you have to turn that 5 into a negative?
No, because it's related to x minus 5.
Oh, okay.
Okay, so when I say synthetically divide by 5, that means do that. That means it's related to x minus 5. So what would I put here? 1, negative 5, negative 4, 20. All right, let's see. Some of you guys did very creative stuff here, but this just drops. 5 times 1 is 5. Add. 5 times 0 is 0. Add. 5 times negative 4 is negative 20. Is that cool? And then look what we get. What is this? This was cubed, so what is this?
Squared.
1x squared. 0 x's minus 4. Right? If I synthetically divide by 5, by x minus 5, what I'm left with is the other piece, of course, right? If I divide 18 by 6, what do I get? 3, because 6 times 3 is 18. So if I divide something by part of its factors, I get the other part. Of course I do, right? Because that's not surprising at all. Okay. So I'm trying to make a connection here, because can we currently factor everything in the universe? Oh, hell no. Shit no, right? We cannot factor everything. So we need to expand our abilities. We need to be able to factor more than we currently can. Okay, so let me do a couple more things to connect what we already know with what we're going to be able to do. I'm going to erase all this. All right, so let me see. Blah, blah, blah. Let's see if it works. Are you working? What was I just using? Was it you? Oh, yeah. All right. Let's see. Okay. So let's say this is f of x. Okay. I want to do a couple things real quick. Let's just do this, just to get us ready for what we're about to do. What is f of, this could get gross, but oh well. What's f of 2? Just take a minute to figure out what f of 2 is. See again? Sorry?
15.
Well, let's see. So this would be 4 times 8, right? 32. Minus 2 times 4 is 8. Minus 2 plus 1, right? So you get 24 minus 2 is 22 plus 1 is 23. So cool. That's not amazing. You guys with me? That's nothing new. Ooh, Jeff, you put a 2 in there. Way to go, buddy. Now, take a minute and synthetically divide this by 2. So what am I going to put here?
4, -2, -1, 1.
Cool. So do that real quick. We're about to do some crazy shit. But then we'll see why it's not so crazy. So let me catch up to you guys. What are you guys getting over here? Holy shit. What? What? Alright, sorry. I'll stop. So bring the 4 down, right? 4 times 2 is 8. Add, multiply, add, multiply, add. Is that a coincidence? No. I want to show you why. Okay. So you guys help me out real quick. What we just did it go in evenly? No. But can you tell me, can somebody help me write what this answer is? And real quick, what did I just divide by actually? What is this related to? X minus 2, is that cool? We just divided this by x minus 2. Is x minus 2 a factor of this? Based on what we just did. Did it go in evenly? No. So x minus 2 is not a factor of this. How you guys doing? Can you tell me what the answer here that we got? What's this answer? 4x squared. Keep going. Yeah, okay, right. Stay with me, stay with me, stay with me. This is kind of nice. Synthetic's not hard, correct? Even if you messed up on the test, it isn't hard. It just is a matter of getting used to it. It's really kick-ass, especially compare this to long division. Yes? This is much better. Okay. So watch this. Real quick, I want to show you a concrete example with numbers. 5 goes into 31. How many times? 6. With how many left over? 1, right? What does this really mean? This means that 31 is 5 times 6 1/5. That's what that means, yes? What's 10 divided by 2? 5. Why? Because 2 times 5 is 10. So whenever I divide, that means the thing I divided by and the answer multiply to be this. Stay with me now. What's 5 times 6? 30. What's 5 times 1/5? That's what that says. 31 is 30 plus 1. Ooh, right? That's why the remainder was 1, because it was 1 bigger than a number that 5 goes into evenly. Okay. So what the hell does that mean? What did we divide this by? What did we divide this by? Here. X minus 2. So it's equal to x minus 2. You left yourself no room, Joe. Times this, yes? Of course it is. If I divide this by this and I get that, this equals this times that. That's what division is, correct? Nothing crazy about that. So this is equal to this. You guys doing okay? I mean, we actually have not done anything new. This is really old shit. Okay. Now watch this. I'm going to do basically what I just did here. If I multiply this in, and I'm going to do it a special way. I'm going to multiply by this first. So this will be x minus 2 times this mess. That's like 5 times 6. What is x minus 2 times this? 23, right? The x minus 2's would cancel, yes? So that is what f of x, that's a way to rewrite f of x. Is that factored? How do we know it's not factored? Because there is a addition, right? Factored means multiplication, not addition. That's not surprising because it didn't go in evenly. So of course I can't factor it using x minus 2. It doesn't go in evenly. You guys doing okay? Why does this make sense? Because that's the remainder. That's how much excess shit there was. If this would have been 23 less, this would have went in evenly. But now watch this. What do you get when you put a 2 in? What's this? What's this? When I put a 2 in? 0 times who cares? So of course you get 23, right? So what does all that mean, Jeff? What the shit? What does all that mean, man? You get your numbers flying all over. What that means is this. Let's do a fresh problem. If I give you a polynomial function, let's see. Right, and I want to know what f of 3 is. Right, not one of our favorite things to do. Is that true? Even if you plug in the calculator, it takes a while, right? What I can do is I can synthetically divide this. What am I going to put here? I'm going to synthetically divide this by 3.
-6.
5, -6.
0.
0.
2.
Somebody just go, ooh. I like it. So let's see, let's try it. 5 comes down, multiply, add. Oh, this is going to get out of control. Add. Multiply, that's 81. Add. Multiply, that's 249. Add. Okay, oh my God, hopefully I did that right. 249. Yeah, okay. Yes?
Where did the 0 come from?
So this means how many x to the 4th, right? Yeah? How many x cubes?
-6.
How many x squares?
Oh, 0.
So synthetic division, in order for it to work, all the places have to be represented. In fact, if I wanted to say there's 104 people coming, and I write this, are they gonna put enough chairs out? 104 people coming, and I write this, because I didn't represent no tens, right? Like it. So when you start doing things like division with polynomials, you have to represent all the places there, the same way we do with numbers. Yeah, I like it. It's a good question though, I like it. Now real quick, can somebody just plug in the calculator this? 5 times 3 to the 4th minus 6 times 3 cubed plus 2 times 3 minus 7. Let's see what we get. I'll see if I can beat you guys. Let's see. Oh, screw it. Let's see. 162 plus 6 minus 7.
42?
What? Yeah, 242. Right, you get 242. I was almost there. So that's what's called the remainder theorem. Again, another example of how math people don't name things very creatively. The remainder means something. We call it the remainder theorem. So if you synthetically divide a given polynomial by something, the remainder is what you would get if you plugged it in. The reason that works is because this piece will be there. It will be x minus 3 now. When x is 3, all this shit cancels, and the remainder is the only thing that's left. That's why it works. Okay, maybe.
Why do you want that?
Huh?
Why do you want?
How do I want what?
No, why do you want to do the remainder theorem?
Oh, the idea of the remainder theorem is useful for what we're about to do, and it's also useful by itself. It was actually sort of quicker to do this than it was to do this. So imagine if I had 8x to the 11th minus, and I want to put a 7 in there. I would actually much rather do synthetic if I had to do it by hand, right? Now, by itself, that's not very, that's kind of lame, because we all have calculators, right? Even though phones, now you got calculator with you everywhere. But it's going to help us interpret what we're about to do in terms of getting stuff that we need to be able to graph things, right? This remainder theorem. So what is one of the best remainders to see if I'm trying to factor something? 0. I want to see a remainder of 0 because that means what I just divided by is a factor. So if I was trying to factor this, this would suck to see because that means x minus 3 is not a factor. Shit. Maybe. So let me ask you something very direct here. If I have a polynomial, so I have this polynomial p of x, right, equals ax to the n, blah, 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 blah. Right, it's some big ass polynomial. And p of 2 is 0. What is a factor of polynomial p?
X minus 2.
Right. If I plug a number into a polynomial and it equals 0, that must mean, since 2 made it 0, that must mean that this is a piece of the factorization of it. Because if it makes it 0, then x minus 2 must be there somewhere, because that would be 0, right? How do I find the zeros? Don't we factor, and then set each factor equal to 0 and figure out the zeros? So this is just going backwards. If 2 makes it 0, this must be a factor of it. Okay, maybe. Okay. So for example, let's see. Oh, this will be exciting. Let me see. I should have come. I do have one kind of prepped, but I don't want to do that one because I want to do that one later. So of course, I want to on the fly create a problem. So give me a second. Blah, 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 blah. Oh, this is exciting. let's see if I can mess this up. All right, let's see if I did this right. So let's say I have x cubed. Okay, let's make things regular for Jeff. That would be nice. Plus x, no, minus x squared minus 14x plus 24. Does grouping work on this? Think about it for a second. Would grouping work?
No.
I'm just verifying it did it correctly. Yes, okay. Right? Can you quickly see grouping won't get you anywhere?
Mhm.
Take an x squared out of here, you get x minus 1. What? But I promise you, this is factorable. Take a minute and synthetically divide this by, I don't know. Well, let's do this one first. Synthetically divide this by 1. You guys start to pick up on how important synthetic division is. If you're not really comfortable with synthetic division, that is your immediate focus. Get comfortable with synthetic division because we're going to be doing it a lot. So you want it to be the easy part of the problem. So let's see, we bring down the 1, multiply, add, multiply, add, multiply, aw. Now did that work? Did it go in evenly? No. Did I get that right? I did quickly.
That's what I got.
That's right. Okay, good. All right. At least 2 of us got it right. Or both wrong. So what is not a factor of this? Can somebody tell me what, based on what we just did, what is not a factor of that? X minus 1. Not a factor of that, right? Okay. But what can you tell me? There's one thing you can tell me that this is useful for. What is f of 1? 10. And we can check it real quick. 1 minus 1 is 0, minus 14 is negative 14 plus 24 is 10. Right? Woohoo! Now, synthetically divide this by 2. Let's see. Yeah, 2. Let's see what you get. Right? So what is a factor of this? X minus 2. I love it. Now I want to show you something that's going to become really useful. This would be what? Don't write this down, but what would this mean? X squared plus x minus 12, right? Now watch this. This is going to be really nice. I want to synthetically divide what I have by 4. I could just keep going. So you can just kind of keep going. So synthetically divide by 4, Jeff? Is that right? Negative 4. All right. You bet. Next thing we're going to talk about is how to get these numbers to try, right? So if I synthetically divide by negative 4, let's just do this. 1, negative 4, negative 3, 12, 0. Yes? And then 0, 0. There. You guys with me? Is that cool? Did that go in evenly?
Mhm.
So can you tell me, this meant what? That this equals, what's this?
X minus 2.
X minus 2. What's this? X plus 4. And what's this? This was x squared, right? So this is now x minus 3. So that could be the first step in a problem. I give you this, you use synthetic division to factor it, and now you're able to get the x-intercepts, you see the multiplicities, you can determine blah, blah, blah. You guys see what I'm saying? So the way this kind of section works is we talk about the ideas of graphing, and then we say, oh, now we're going to start the same kind of problem in a harder place. Something that you can't factor directly. You actually have to use synthetic division to factor. Maybe? Maybe? So, can anyone tell me why, if I was given this problem, not just because we already know the answer, let's pretend like we just were given this problem, why would it not make any sense to try to divide by 7? I can tell already, ain't no way that's going to work. It doesn't go into 24, right? So real quick. What is negative 2 times 4 times negative 3?
24.
Of course, yes, because doesn't the last term come from the last terms of each thing? So doesn't it make sense? What are all the things that could have worked then? 1, 2, 3, 4, 6, 8, 12, 24. Okay, right? In fact, that's half of the list, plus or minus, right? So we're going to get to a point, and I think you guys can already see how to construct this list, because you need to first construct the list of all the possible things that will work, and then you try them. Yes? Does that kind of suck? How long is this list? 16. You guys see that? There are 16 numbers up here, yes? Positive, blah, blah, and negative, blah, 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 right? And there are 4, 4, 8 times 2, 16. There's 16 numbers up there. What if you get unlucky and you pick several wrong ones in a row and your time is running out? Yes? Well, that's too bad. No, I'm sorry. We will talk about ways to cut that list down. But you guys start to get a feel for how this is going to work? I develop a list of all the things that might work. Then I try them until I get some that work. And then that way I start to whittle this thing down. I start to break it up into its parts. Yes? If 2 works, that means that x minus 2 is a part of it. And then I try another one. Maybe. Okay. So, help me out here. I'm going to erase all this, ready? Well, I'm already started. It's going away. It's gone. Here, let's do this. Well, yes. Well, let's see. I'm trying to think about what order to do this in. Let's see. So let me give us a polynomial. Well, let's see. Hold on here, everybody. Let's do it again. I'm going to make one on the fly here. This is always exciting. Blah, 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 blah. Blah, 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 blah. Okay, hopefully that works. Okay, let's see. X cubed minus, or plus 2x squared minus 15x minus 36. Okay. Yeah. Nice and gross. Okay. So let's first make the list of all possible rational zeros. Good Lord. Because couldn't an answer to this be square root of 7? We ain't going to find it this way. So we just focus on the rational stuff first, and then maybe quadratic formula will help us find if there's any radical answers. Is that all right? So what are those?
1 with plus or minus.
I like it. Just start doing all the factors of 36, right? 1, 2, 3, 4, 6. And see, it's kind of nice. What's special about 6 here? Isn't that the midway point?
Yeah.
In fact, let me see if you guys really get this. When you start making a list of factors, don't you reach a point where you start to just pair them with the numbers that came before, right? Because now it's going to be 6 times 6. So now I'm going to do 9 times 4, right? That point is always less than or equal to the square root of this. And square root of 36 is 6. So once I get past the square root of the number, at the square root of the number, I know I'm at the turnaround point. I have no idea if you guys are with me or not. You have to first start, and now I can just start going, 6 times 6, so now it's 4 times 9, 3 times 12, right? Now it's not a free-for-all. 2 times
18.
and 1 times 36. How long is our list now? 18 numbers up there, yes? 18 of them. Because it's plus or minus. Right? Screw you, Jeff. All right. I won't do all that shit. So, one of the very first things I like to show you, I don't think the book even talks about this, and it's the one that's more useful, which is kind of funny. Let's try to synthetically, I'm not even sure if this is going to work the way I want it to, but let's find out. Let's synthetically divide this by 6. So 1, 2, negative 15, negative 36. Let's see what happens. Yeah, this will work. All right, I love it. This will work big time. I really want this. This is going to be so freaking cool. I know all of this sucks. I know it does on some level. I don't know if anybody out there is finding this intriguing at all. I know it all kind of sucks. But the biggest, suckiest thing about it is how many freaking things I got to check. It's going to take all freaking day. So what do you guys get here? Let's see. Let me catch up to you. 1, multiply, add, multiply, add, multiply? Is that right? Add.
162.
Okay. So is x minus 6
No.
part of the answer? No. So on its face, that sucks. But real quick, wouldn't this be x minus 6 times, help me out,
X squared
x squared
minus x plus x
plus 8x
plus 33
plus 33.
plus 162 over x minus 6.
All right, let me see if I can really get you to go with me on this. Even if you don't quite understand it, you can kind of memorize this shit, but I really want you to understand why this makes sense. We're trying to find the zeros, correct? We're trying to find numbers that make the thing 0. 6 doesn't make it 0 because there's a remainder, yes? But watch this. If I put in there, if I put 9 in here, isn't this positive? And isn't this positive, 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 positive? Any number I put above 6 will make this something positive. You guys with me? So is there any way that a number above 6 makes it 0? What's the only way this could come out to be 0 is if some of these canceled with each other, right? But aren't they, if I put any number above 6, are you guys cool with that's positive, 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 and positive, right? If it was below 6, this could be negative, couldn't it? Because 5 minus 6, for example, is negative 1. I really want you guys with me. Trying to find it where there's 0. So any number above 6 makes this greater than 0. So will any number above 6 be an answer? Will any number above 6 make this 0? No. So we call this an upper bound. Everything above 6 I can forget about, right? So what does my list look like now? It looks like plus or minus 1, 2, 3, 4. I can eliminate 6 because it didn't work. And because all of these are positive, this is an upper bound. I can eliminate everything above 6. So screw these guys. But then I still get the negative 6, 9, 12, 18. But I just eliminated positive 6, positive 9, positive 12, positive 18, positive 36. I just eliminated 5 numbers in one go. So does everybody understand that list we made? Does everybody understand that list we made? How to get those numbers? Shit. All right, that's a good thing to ask me right when we do it. Where did this list come from? Where did that list come from? Factors of 36. Because if this thing does factor, won't it be like x minus a number, x plus a number, x plus a number, blah, blah, blah? Yes? In fact, it's a cube, right? So it would be this. X times x times x is x cubed. Number times number times number has to be 36. So what's the only numbers that do that? These. So why would I try 7? I know that's never going to work because it doesn't go into 36. It can't be one of those numbers. So 36 would come from the product of these. So why would I include something like 7 in my list of possibilities? Okay, all right, that's step 1. Okay, good, I'm glad I checked. So we got the list. The list is long. Don't you want ways to cut that list down? Yes. You're going to have to go through and try all of them if you can't find them. So it would be great if one doesn't work, but the answer tells me, oh, these won't work either. That's awesome, yes? Instead of having to do every single number in here and getting unlucky the whole time, I could do one number and the answer might tell me, oh yeah, everything on that side doesn't work either. Okay. So that's what my list looks like now, right? Okay. 6 didn't work, so that's why I threw 6 out. Let's try -6. So what is this related to? If this works, what would be a factor? X plus 6. So always keep in mind, when I'm synthetically dividing my number, it's related to where it would have come from as a 0. In this case, x plus 6. Right? So if I do this real quick, let's see if this does what I want it to. 1, -6, -4, 24, 9, -54, -90. Notice how these signs alternate, don't they? Positive, then negative, then positive, then negative, right? So real quick, help me out. Based on what we just did, x plus 6 times, what's this?
X
Squared, good. Stay with me now. All right, here we go, you ready? If I put a number less than -6, is there any way this will be 0? If I put a number less than -6, like -7 or -8, right? If I put a number less than -6, isn't this just positive always? X squared, right? That's positive. If I put a number less than -6 in here, what would this term be? Positive or negative? It's -4 times the number, and I'm putting a number less than -6 in there. This would be positive, yes? Like -4 times -7, for example. So that's going to be positive, right? So plus, this is always plus, right? Because it's freaking 9. And if I put a number in that's less than -6, this is going to be negative times negative is positive. All right, this is weird. But again, I'm trying to find what makes this 0, right? And right now, if I plug in anything less than -7, there's no way in hell this is going to be 0 because it's all positives. It's going to come out to be some positive number, not 0. Maybe, yes? Okay. All right. So let's do an example. So if I put in -7, right? So this would be -1, yes? So that's not 0, right? So the only way -7 could make the 0 is if this piece is 0, right? This will be 49. -4 times -7 is plus 28, right? 9 is 9. And this would be minus 90 over -7 plus 6 is -1, so that becomes plus there, right? Is that cool? The negatives cancel? Could this possibly be 0? No. If I start with 49, what's the only way it would end up 0 is that at some point I'm subtracting something, right? If I have nothing but positive numbers that I'm adding, could it ever come out to be 0? If I have a bunch of positive numbers and I add them, can it ever come out to be 0? Shit, no, right? So what this means is, when I divide by a negative number, and these switch signs, that is a lower bound. Anything lower than this won't work. So this is a lower bound. So then I can do this. Screw you guys. -6 didn't work, and nothing below -6 is going to work. I can throw all those out. How big is my list now? 8. So I started with 16. I did 2 divisions, and I cut my list in half. So that's the idea of upper and lower bound. So if I divide and I get everything positive, if I divide by a positive number and I get nothing but pluses, that's an upper bound. You can throw out anything above that number. If I divide by a negative number and it alternates signs, that's a lower bound. I can throw out everything below that number.
Do you throw out the number itself?
This number I throw out because it didn't work.
Okay, yeah.
So I can throw it out just because of that.
So it's the number and then everything above it.
Yeah. Now, if this would have had a 0 here, then x plus 6 would have been an answer. But since these alternate signs, I could have thrown out everything below -6. Okay, maybe. So, let's do this. Yeah, I'm going to erase all this. Ready? Let's talk about something that's directly related to that. So let me collect what we just did. So if dividing by a number causes an answer by a number greater than 0, so a positive number. If dividing something by a positive number causes the answer to be all positive, that's an upper bound. You can throw out everything above it. So if I synthetically divide by 2, and I get nothing but positive answers at the end, everything above 2 can be thrown out. They can't make it 0. There's no way they can make it 0. If dividing by a number less than 0 causes the answer to be all alternating signs, it's a lower bound. You can throw out everything below that number. That's really useful when you have a big ass list. That's why normally when I have a big ass list, I choose some numbers in the middle, just to see if they're going to be upper or lower bounds, right?
Does the first one have to be a positive or negative?
Yes. So you divide by a positive number to find an upper bound. You divide by a negative number to find a lower bound.
I mean, like when they alternate.
So yeah, if I divide by a negative number and the answer is all positive, that doesn't tell me shit. Doesn't tell me a damn thing. If I divide by a positive number and the answer alternates, doesn't tell me shit. Doesn't tell me shit, right? So an upper bound comes from dividing by a positive number and getting nothing but positives. So if I do this, 4 is an upper bound. If I do this, and I get negative, positive, negative, positive, negative 4 is a lower bound.
What if you get positive, negative, negative?
Yeah, as long as they alternate, you're golden.
What does it look, what does an upper and lower bound look like? Like on a graph?
No, all right, so I understand why you're saying graphically, because you're thinking like it's going to turn around or something. That's not what this means. It just means that if 4 comes out with nothing but positives, nothing above 4 will work.
Okay.
That's why we call it an upper bound. It is the highest thing the answer could be. So anything above that, I can throw out. Same thing here. Nothing below negative 4 would work. If I got that, for example,
Yeah.
you can throw all that shit out. Yeah. That kicks a lot of ass. That kicks so much ass. And I think this is something, I can't remember if this book even talks about upper lower bounds, but either way, I want you to know about it. Okay. So let me momentarily ask you something that seems unrelated, because we're about to do something kind of related to this. Do you guys know the official name for this? You guys know the official name for this? XY plane, coordinate system, sure. There's another word starts with C.
Cartesian?
Dude, this is called the Cartesian coordinate system. Yeah, Cartesian plane. Anybody ever heard that before? Cartesian? Sounds like artisan, sounds like, ooh, is that the good bread? Right, but this is the Cartesian, excuse me. All right, so there was a guy named Descartes, who the urban legend is he was sick in bed and he was watching a fly walk on his ceiling, and he came up with the idea of a coordinate system to kind of locate points. Is it true? I don't freaking know, right? Okay, but you can kind of imagine, sort of like the apple on the head of Newton. He's like, oh, gravity. So this guy, oh, fly, XY plane, of course. You never know. Could be true. So we're about to do something else that Descartes discovered. He discovered several things, right? And this one is a big one because we see this all the damn time. I'm going to erase this. So we got upper and lower bounds, and I'm going to show you one more thing that will help you cut down your list, right? Okay. So another thing Descartes came up with is called the rule of signs. And it's very related to the bounds idea. If I have a polynomial, let's say and the polynomial has no sign changes. What do I mean? Does the sign change from term to term anywhere?
Mm-hmm.
Nope, the sign never changes. That means that there are no positive roots. Now let's think about why that's true. If I plug a positive number in here, is there any way it could come out to be 0? Because the only way, if you throw a positive number, you start with a big positive, the only way to make it 0 is if you subtract something, and you're never subtracting anything, yes? Maybe. Okay.
Can you say that again?
So if the polynomial has 0 changes in sign, that means there are no positive roots. So when I make my list, plus or minus stuff, and it looks like this, I can throw out all the plus stuff. I can cut my list in half immediately.
Because you can't subtract anything?
Say again?
Because
Yeah, because if any positive number I put in here, won't it just be positive plus positive plus positive? There's no way that could become 0, right? And what are we trying to find? The zeros. So could a positive number make this 0? No. Okay, maybe. So that's one thing. Let's look at another one. Let's call that P1. What if I have this guy? Yeah, sure. Good Lord. All right. How many times does the sign change here? 1, 2, 3, 4, 5, right? So it changes everywhere. So could there be some positive roots? Yeah, I don't know. There could be. But what about negative roots? Well, let's see. If putting a negative x in, what does that do to this? Let's see. We want this to make sense. So if I put a negative x in, can anyone figure out what this becomes? Positive, right? So negative to the fifth is still negative, times negative is positive. This is always positive, right? So every other term, all the odd terms are going to become positive. You guys understand? If I put a negative inside of an odd power, it's going to stay negative. If I put it into an even power, it's going to become positive. If putting a negative x in makes there be no sign changes, then there are no negative roots. Same reasoning, actually. The exact same reasoning. If I put a negative number in, everything now is positive. There's no way it could be 0. Again, what good does that do? If my list of numbers that could work would look like this, and this is true, I can kill all the negative. I can cut my list in half immediately before I do anything. Oh, holy shit. Yes? So we can make that list. That list will very, very often be huge. So one of the first things I want to do is, good Lord, I want to cut out some of that shit so I don't have to synthetically divide by all of it, especially if I'm an unlucky person. Can you guys imagine there is some luck involved here, correct? If you don't pick the right thing to try, it's going to take you longer. So the first thing you want to do is cut that list down. Okay, maybe.
Why does the x to the fourth stay positive when you...
What's a negative to the fourth power?
Oh.
So all the even power stuff stays the same. All the odd power stuff changes sign. I like it. See how that sounds a little bit like upper lower bounds, because this is all positive and this one's always alternating, right? The bounds and this idea are actually kind of related. I just don't want to get into that. It's a little bit messy, but okay. So let's put this into practice. And actually, before I do that, I got one more thing to show you about creating the list of possible answers. Is this, have you ever heard anything like this before in your life? Okay, so you think it's going to take a little while to get used to it? That's it, yeah. So get off your own back if it doesn't make sense yet. It's going to take some time to kind of use it and get used to it. I really hope it makes a little bit of sense right now. We're trying to make this thing 0. So the only way this thing could be 0 is if some of these subtract and others of them add. So if they're all freaking positive, it's not going to make zeros. Now look, if I put a negative number in, could there be negative roots? Yeah, because if I put a negative number, isn't that negative? And that's negative? And that's positive? And that's negative? And that's, oh, it could come out to be 0. So there could be negative roots, but there can't be positive roots. Because all the positive numbers are going to be all pluses. It can't make 0. Okay, maybe. many erasers do I need? One more thing. Oh, you're gonna be so excited. You're gonna love this. Can you guys tell me what the zeros are for this? What are the zeros? The roots. You just read them off, yes? Can you? Can anybody? So what's the zero for this? Start with the easy one. 7. Anyone see this one?
1 over 2.
1/2. Add 1, divide by 2. What about this one? Subtract 5, divide by 3. Negative 5/3, yes? You guys with me? I think I'm gonna do this. All right. Oh God. Okay, you ready? Yeah. Why not? Why not? Let's do something really gross. I'm gonna multiply this out. You can just watch if you want to. And you're gonna mark it that works. I'm just gonna multiply this stuff out. You ready? All right. 6x squared minus 3 plus, so it's plus 7x minus 5 times x squared minus 14x plus 49. It's exciting, Jeff. Then you get 6x to the 4th. You don't need that. Minus, oh shit, Jeff. 4 to 84 plus 7, so it's minus 77x cubed. Don't worry about what I'm doing. Minus 8 to 98, minus 98x squared, minus 5x squared, so minus 103x squared. It doesn't, to be honest, the numbers don't even matter, but you're going to try to make these right. Plus 60x, oh, let's see, 343, 60, 403x, minus, what would that be, 250, so 245. Shit. All right. Now, real quick. These are the answers, yes? These are the zeros, right? Where did this 2 come from?
2x.
The first number, right? The first coefficient, yes? Because how do you solve this? You would make it equal 0. You would add that, divide by that. This came from the last dude. This came from the first dude, yes? Yes? So, the earlier problems we did, what was the number here? Wasn't it 1? Okay, so it didn't mess anything up. Now it's 6. Shit. Aren't some answers fractions? Yes, because this will break up into 2 and 3 and 1. Yes? So, when I go to make the list here, it's going to be all factors of 245 divided by all factors of 6. I really want this to make sense because where did this answer come from? The 1 came from the last guy. The 2 came from the first guy. The negative 5 came from the last guy. The 3 came from the first guy. So if I want to make, so those are the actual answers. But if I want the list of possible answers, I take all the factors of the last guy divided by all the factors of the first guy. Now, man. So 245, is that correct? Let me see. 250. Yeah. Okay. 245 came from 5 times 49, right? So it's 5 times 7 times 7. Is that cool? You guys with me? Yes? I think? Yes. Okay. So aren't the factors of 245, that would be plus or minus 1, 5, 35, 49, 245. Oh shit, you guys are right. Isn't 5 a factor? All right, left out 7, Jeff. Good job, buddy. 7. 5 is a factor, 7 is a factor, 35 is a factor, 49 is a factor, and of course 245 is a factor, right? 245 is kind of a gross number, so just deal with that. Divided by plus or minus 1, 2, 3, 6, all the factors of 6. Oh, you're excited, I can tell. You're all like, ooh, this sounds great, Jeff. Best thing I've seen yet in math. So how do I make the list? Well, divide everything by 1. Wouldn't that be 1, 5, 7, 35, 49, 245, right? Divide everything by 1. Now divide everything by 2. 1/2, 5. It wasn't 1/2 one of the answers? 1/2, 5 halves, 7 halves, 35 halves, 49 halves, 245 halves. Then divide everything by 3. 1/3, 5/3. Wasn't 5/3 negative 5/3, right? Was one of the answers, yes? 5/3, 7/3, 35/3. Holy Jesus, what? Okay. So that is especially where you want bounds to help. Look how long that freaking I didn't even finish it, right? That's a long ass list. So if I do bounds and I do Descartes' rule of signs, I might be able to chop that down some. Oh shit, I totally forgot about the rest of Descartes' rule. Damn it. That is the whole story. So why didn't this show up before? Because the first number was a 1. And the only factors of 1 is 1. So it didn't make any fractions. But now when the first number is not a 1, oh shit, we know it messes things up, and that's what it does. So real quick, before I finish up Descartes' rule, let's do this. Okay. Yeah, let me do this. Let me give you an actual thing to look at. We'll kind of do this together. Well, actually, no, we're not going to do this one yet. We'll do another one together first. Just hold on to this right now. We'll do this second. I want to do a different problem next. But I'm already giving this out, so I might as well finish doing it. We won't do this problem quite yet. I want to do a different problem first. Where's that different problem, Jeff? Here it is. So let's say I've got this. No, not you. You. So don't worry about that paper yet. Just put that down for a minute. Watch this. All right. Let's first try Descartes' rule of signs. Doctors, right? Descartes' rule of signs. So what does that tell us? So are there possibly positive roots? The only way there would be no positive roots if these were all the same sign, if these are all positive. Are they all positive? No. Right? So since f of x has many changes in sign, there could be positive roots. How do I check to see if there's negative roots?
So it's alternate.
It's alternating, yeah. The official way is to do f of negative x. But you can also just see that it's alternating. If I do this, then all the cube terms change signs. And the x term changes sign. Right? If I put a negative here, that cancels that negative. So are there any negative roots? No. F of negative x ends up with no changes in sign. So there's no negative roots. So when I go to make my list of possible zeros, I don't have to put plus or minus. You guys with me? Is that going to happen every time? Nope. Nope. Now, tell me this though. F of x has how many changes in sign? 1, 2, 3, 4. 4 changes in sign. So watch what this means. Since f of x has 4 sign changes, there could be 4 positive roots, positive real roots, if, I really want you guys with me, where would complex roots come from? If I had a problem, where would the complex roots come from? If I end up with like x squared plus 4 or something quadratic, right? And then I go to do it. So I really want this to make all this sense. I've said this before. Complex roots have to show up in pairs because they would come from like quadratic formula. What's in the quadratic formula? Plus or minus. So if there were complex answers, what's the lowest number of complex answers there could be? 2. There can't be one complex answer. There can't be. They have to show up in pairs. So either there's 4 positive real roots or 2 positive real roots or no positive real roots. Because if it's not real, that means there would be 2 complex. So there could be 4 real positives. If there aren't 4, there must be 2, because that would mean 2 of them are complex. And if there aren't 2 real, there must be no real. All 4 are complex. So that actually is not helpful at all. This one is crazy helpful. So let's make the list. How do I make this list? What are the factors of the last number? List of possible rational roots. So on the top go the factors of 8. And I don't have to put plus or minus now, right? Because there's no negative roots. So 8, what's the factors of 8? 1, 2, 4, 8. The first number is a 3. So on the bottom goes the factors of 3. Is everybody cool? Why am I not putting plus or minus? Because specifically, I know there's no negative. In general, you have to put plus or minus, but in this case, I know there's no negative answers. So I'm just, pause it. So if I divide these by 1, so make all the ratios you can, that's 1, 2, 4, 8. Any of those could work. What fractions could work? 1/3, 2/3, 4/3, 8/3. So let's try this. Let's see if you guys. Now should be the sort of easy step. That's all new shit. Everybody pick a number. I'm almost certain nobody's going to pick a fraction, but maybe me saying that, maybe somebody's going to pick a fraction. Pick a number and try to synthetically divide this by it. Let's see if anybody gets one that works. Your prize will be me going, oh good, you did it.
Why are we doing it now?
Say again?
Look, why are we doing it now?
Aw. Yeah. So if you get one that works, let me know. Nobody's got one that works yet? Yeah, you got one?
I think 2 works.
2 works. Okay, let's take a look. Oh crap, I keep forgetting. You're dead. Let's see, 2. So 3, negative 7, 14, negative 28, 8. So let's see, 3, multiply, add, multiply, add, multiply, add, multiply, add, sweet! Oh, sorry, yes.
Oh no, I also got one number.
You got another one?
Yeah.
Okay, hold on. What does this mean so far? This means that what goes in? X minus 2, let me collect you down here. X minus 2 goes in. And what would this be? 3x cubed minus x squared plus 12x minus 4, right? Okay, now, what did you get that works?
1/3.
1/3. Ooh! So if I try to synthetically divide this by 1/3, once you get one that works, never use this again. Why would you? Because now you've gotten it better, now it's this, right? So let's see. So I know you did it on this. Let's see if it should work. It has to work no matter when I do it because it's an answer, right? So bring the 3 down. 1/3 of 3 is 1. Negative 1 plus 1 is 0. 1/3 times 0 is 0. 12 plus 0 is 12. 1/3 of 12 is 4. Negative 4 plus 4 is 0. Anybody get another one? And another one. No? Try negative 4. Is negative 4? Let me see. Negative squared. No, I guess not. It's not going to work. Because what is this?
All
X squared plus
Yeah, let's see. So what do we got? X minus 2. X minus a third. We're going to make that better in a minute, right? X minus a third. Is that cool? And then what's this mean? This was x to the 4th, right? So this is x cubed. So this would be x squared. 3x squared plus 0x plus 12. Can you guys all see that? I put it way down there. I'm sorry. Real quick now, watch this. Do you see how there's an extra factor of 3 here? I can just put it here. So this is 3x minus 1. Do you guys see anything there that would be complex answers? What makes this 0? How do you solve that? What makes that 0? How do you solve it? Sorry? Yeah. Well, that's one answer. If I subtract 4, I take a square root plus or minus. What is the square root of negative 4? 2 I, because it's negative, right? Square root of 4 is 2. Square root of negative 1 is I. So there were 2 complex answers. How many real answers did we get? 2. And how many complex answers did we get? 2. In fact, what did we say here? There could be 4 positive real roots or 2. There were 2. There could have been none. That would have sucked. If there were none, that would mean that nothing in that list works. We would have went through the whole list. I'm never going to do that to you. Don't worry. How long is that list that we made right now? 8. How long could it have been if we didn't do this? 16. Is this useful sometimes? Very. Is it useful all the time? No. Most of the time, doesn't do shit for you, to be honest. But you might as well check, right? Because if it does work, it cuts your list in half. Maybe. So, what I want you guys to do, this problem here, the x to the 5th plus x to the 4th, blah, 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 blah. Right? Do that problem. Right? Everybody see that? The handout I just gave you? Don't worry about the side that says graphing rational functions. We'll get there. That's the next section. Worry about the side that says finding zeros of polynomials. Everybody got their test back, right? Okay. Why is this one nicer than the one we just did?
Coefficient in front of 5x.
Yeah, the coefficient, the first thing is a 1, that's awesome. Right, I don't have to make a bunch of ratio, I'm not gonna get a bunch of fractions. Let me catch up to you guys just a little bit. What's this list look like?
1, 2, 4, 5.
1, 2, 4, yeah, 5. Yeah, square root of 40 is about 6, so I know I'm at the turning point. So then I can do 8 times 5, 10 times 4, 20 times 2, and 40 times 1. So that's the list as it looks now. How many changes in sign are there in the function itself? 1, 2. So as you move through, aren't there 2 changes in sign? So that means there could be 2 or 0 positive real roots, because either there's 2 positive roots or there's 2 complex roots. So it always goes down by 2. So it gets interesting when you look at f of negative x. What's f of negative x? Negative x is a fifth. This stays, right? All the even powered ones stay the same sign. All the odds change, right? So this has become plus 29x cubed. This stays the same because x squared kills the negative. This changes. And 40 is just 40. So how many changes inside of there? 1, 2, 3. So there could be 3 or 1 negative root, which means you're guaranteed there's 1 negative root. So what I think of when I see that is, I'm going to try the negative ones first, because I'm guaranteed there's at least one of those that could work. There might be 0 positive ones. Oh yeah, we're going to do that next, yeah. So keep going, sorry. So make sure you got the first parts okay. So now do part C. Make sure this stands out. See, this is where the calculator definitely comes in here. 1, 8, 9, 72, 43. 8 times 43 is 344, is that right? Interesting. Yeah. That's 309, I believe. 8 times 309 is 2400 something. This is big positive, times 8 is bigger positive. So I want you to realize, I will let you do what I just did. At some point you see it's not going to work. What becomes important then is it an upper bound? Do you guys understand what happened here? 309, you can double check my math. 309 times 8 is 2400 something, plus 142 is a big positive, 8 times a big positive is a bigger positive, plus 40 is freaking positive. All that matters now is, it's not going to be 0 at the end. There's no way. But how do I interpret the results? They're all positive, therefore 8 is an upper bound. So in my list, 8 didn't work, and neither will anything above it. Because the answer came out all positive. There's no way that a number bigger than 8 could make that 0. Let's see. So at the beginning, I want you to be specific. Is that right? Sounds right. So negative 216, thank you. So that's negative 251, and negative 8 times that is like 2008, that's big positive. Times negative 8 is big negative, so that comes out negative. Right? At some point I see it's not going to have a 0 remainder. Then the actual number doesn't matter to me. Now I just care about, what do I see here that tells me this is a lower bound? All change. change. So everything below negative. So now what can I do to my list? I can just basically do this. Go away. 8 didn't work, and anything above 8 won't work. Negative 8 didn't work, and everything below negative 8 won't work. Screw that part of my list. Right? And now, of course, now that's the best we can do. And now we just start trying stuff. And like I said, I would try the negative stuff first because I'm guaranteed. I might have 3 answers or 1 from the negative, so it depends. You could find some, yeah.
To test the bounds, do you usually like start at the middle number?
Yeah, I start in the middle somewhere. Because that gives me a decent chance, so there's no reason to try 40 first, right? It might work, but if it doesn't work, it's not gonna help you, right? So I normally kind of start in the middle, just because that has a higher chance of being a bound, and it will tell me something, right? Maybe.
Should you test another bound? Like, should you test 4?
Yeah, you can try to divide by 4. Now, when you start making guesses, it could still be a bound, right? So we can even try 2, and if 2 came out to have nothing but positives, then I can forget about positive 4, positive 5, right? Did anyone get something that works from the leftover list now?
2.
2? Let's see. 2, 1, 2, 3, 6, negative 23. Really? Does 2 work? 1, 2, 3, 6, negative 23. You got 2 to work with, negative 46. It doesn't look like it's gonna. Well, maybe it will. That'll be negative 131. I don't think so. No. Huh? I don't think that'll work, right? Must have doing something really silly.
81.
Yeah, how did you get negative 151?
I have no idea. Oh, because they multiply. That's good job, Jeff. So it's negative 81. That's better. And then twice that. Oh, this might work. You're right. Negative 162. I don't trust myself anymore. Negative 20. Negative 40. 0. Yeah.
Yeah,
So I have more
22
faith
was a
in you.
roller coaster for me too, for the exact same reason. This isn't gonna work.
I like it. Okay. Yeah, it turns out if you add correctly, it has a chance. All right, cool. So we got 2 to work. Could 2 work again?
You try it.
Could 2 work again? Couldn't I have an x minus 2 squared? So just because something works, don't throw it away. It could actually be another answer. It could work again. Did anybody else get something that works besides 2? Huh? Negative 4? And you got something?
No, I was asking a question.
Yeah, go ahead.
So what do you mean by 2 could work again?
Oh, what does it mean that 2 worked? What do I know so far as a factor of the function?
It's just like 0, okay?
What does that relate to, sorry? Since 2 worked, what's a factor of that?
Oh, x minus 2?
Couldn't this show up twice?
Oh, okay.
So 2 could work again. In fact, it could work like 4 more times, technically, right? It won't, but it could. So you could try 2 again, but somebody said that negative 4 works. Is that what you said? Let's see if we can trust Jeff anymore. Negative 4, negative 1, 4, negative 19. Ooh, you're going, Jeff. What is that? 6, 3, 76, negative 5, 20, 0. Yeah! Now what's interesting, now watch this. Oh, that didn't really help. Well, sort of. Do you see how my last number is now 5? Do you see how I can go back and, 2 and 4 won't work anymore now? So every time you synthetically divide, the last number is going to change, which actually also eliminates some possibilities. Maybe? So now I would try like 1 or 5, obviously, because that's all that's left. 5 works?
So the opposite wouldn't work?
Say again.
So the opposite of negative 4 wouldn't work? Because it's the opposite.
Oh, I didn't mean to throw out. Yeah, I meant to throw out. I gotta be more careful. Why did I throw out 4? Oh, but yeah, no. 2 and 4 won't work because what are the factors of 5? 1 and 5. right? My new last number is -5. Where did those come from in the first place? Because the last number was 40, right? That came up with all this. Now what's my last number? -5. So now 2 and 4 I know are not going to work. They don't have a chance. So every time you get something that works, that in itself will cut down your list. I like it. So what I got so far? X minus 2, x plus 4. And you said that 5 works?
Yeah.
1, 5, 4, 20. 1, 5, 0. So what else do I add here? And what's this? Can you guys see that that wouldn't factor?
Yeah.
So there's no reason I would try to synthetically do. Basically, when you get to a quadratic, when you get to x squared, and by the way, how do I know I'm x squared? 5th, 4th, 3rd squared. I'm at x squared. I stop and I write it, because either I can factor it or I can't. Right? In which case I either factor it, or if I need the zeros, how do I get the zeros from this? What's the zeros so far? 2, -4, 5. How do we get the zeros from this? Quadratic
equation.
formula. Yes. Negative b blah, 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 blah. Is that that is the technical negative b blah, 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 blah. That's quadratic formula. Just remember that, kids. Okay. Maybe. I think it's enough for today. What do you guys think? That's plenty. So you can look on the other side of that and see what's in our feature, or you can just not look at it if you don't want to, and find out next time. So let me know if you have any questions. Otherwise, I will see you guys